To determine the appropriate conductor size for a 75 horsepower, 380 volt fire sprinkler motor, we need to consult the National Electrical Code, specifically Table 310.15b16. This table provides ampacity ratings for conductors based on their insulation type and ambient temperature. For motors operating at 380 volts, we can use this table to find the minimum conductor size required to handle the motor's full load current. To find the motor's full load current, we need to consult NEC Table 430.250. This table lists the full load currents for alternating current motors. For a 75 horsepower, 380 volt motor, the full load current is approximately 124 amps. Now, referring back to NEC Table 310.15b16, we need to select a conductor with an ampacity rating equal to or greater than 124 amps. Assuming we are using a conductor with THHN or THWN-2 insulation, which are common types of conductors used in electrical installations, a No. 2AWG copper conductor would be sufficient. A No. 2AWG copper conductor with THHN or THWN-2 insulation typically has an ampacity of around 130 amps at 75 degrees Celsius. Therefore, the minimum conductor size required for a 75 horsepower, 380 volt fire sprinkler motor is No. 2 ohg. Next, we need to determine the appropriate circuit breaker size for overcurrent protection of the motor. For this, we consult NEC Table 430.250, which provides guidance on motor overcurrent protection. The maximum circuit breaker size is determined by multiplying the motor's full load current by a certain percentage as specified in the NEC. For fire sprinkler motors, the NEC typically allows the use of inverse time circuit breakers which can handle inrush currents during motor starting. According to NEC Section 430.52, the maximum rating or setting for an inverse time circuit breaker protecting a motor is typically 250% of the motor's full load current. However, there may be specific requirements or limitations for fire sprinkler motors, so it is crucial to consult the applicable sections of the NEC and local codes. In some cases, the maximum circuit breaker size may be limited to a lower percentage, such as 175% or 225% of the motor's full load current, depending on the specific application and code requirements. In this case, we are given that the maximum circuit breaker size is 125 amps. It is crucial to follow any restrictions outlined in the NEC or local codes when determining the circuit breaker size for a fire sprinkler motor. For a 75 horsepower, 380 volt motor with a full load current of 124 amps, a 125 amp circuit breaker would provide adequate overcurrent protection, provided it complies with all applicable code requirements. In summary, the conductor size should be a minimum of No. 2 ohg, and the circuit breaker size should be no more than 125 amps. For specific item numbers, consider the following examples. For the conductor, Belton 8760, No. 2 ohg, THHN or THWN-2 is a suitable option. Belton 8760 is a commonly used type of conductor that meets the requirements for motor applications. For the circuit breaker, Square DQ 125 GFC, which is a 125 amp molded case circuit breaker, is a suitable option. Square DQO series circuit breakers are widely used and provide reliable overcurrent protection. It's always important to verify that the selected conductor and circuit breaker meet all applicable standards and certifications for the specific application and location. This includes ensuring that the conductor is listed and labeled for the intended use and that the circuit breaker has the appropriate interrupting capacity and protection features. Additionally, always consult the manufacturer's specifications and installation instructions for the conductor and circuit breaker to ensure proper installation and operation. In addition to conductor sizing, there are other factors to consider when selecting conductors for fire sprinkler motors. These include the ambient temperature, the number of conductors in a raceway or cable, and the voltage drop. The ampacity ratings in NEC Table 310.15b16 are based on an ambient temperature of 30 degrees Celsius, or 86 degrees Fahrenheit. If the ambient temperature is higher than 30 degrees Celsius, the conductor ampacity must be derated according to the correction factors provided in the NEC. This ensures that the conductor does not overheat and that its insulation is not damaged. When multiple conductors are installed in the same raceway or cable, the ampacity of each conductor must be derated according to the adjustment factors provided in NEC Table 310.15 Cone. This is because the heat generated by the conductors can increase the overall temperature within the raceway or cable, reducing the ampacity of each conductor. Voltage drop is another important factor to consider when selecting conductors. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause the motor to operate efficiently or even fail. The NEC recommends limiting voltage drop to a maximum of 5% for motor circuits. To calculate voltage drop, you need to know the conductor length, the conductor size, the conductor material, and the motor's full load current. There are various online voltage drop calculators that can help you with this calculation. In addition to circuit breaker sizing, there are also other factors to consider when selecting circuit breakers for fire sprinkler motors. These include the interrupting capacity, the trip characteristics, and the enclosure type. The interrupting capacity of a circuit breaker is the maximum amount of fault current that the circuit breaker can safely interrupt without being damaged. The interrupting capacity must be high enough to handle the available fault current at the point of installation. The trip characteristics of a circuit breaker determine how quickly the circuit breaker will trip under different overload and short circuit conditions. Circuit breakers are available with different trip characteristics such as inverse time instantaneous and time delay. The appropriate trip characteristics will depend on the specific application and the type of motor being protected. The enclosure type of a circuit breaker protects the circuit breaker from environmental factors such as dust, moisture, and corrosion. Circuit breakers are available with different enclosure types such as NEMA 1, NEMA 3R, NEMA 4, and NEMA 4X. The appropriate enclosure type will depend on the location of the circuit breaker and the environmental conditions. When selecting conductors and circuit breakers for fire sprinkler motors, it is important to consult with a qualified electrical engineer or electrician. They can help you determine the appropriate conductor size, circuit breaker size, and other factors to ensure that the electrical system is safe and reliable. Remember that fire sprinkler systems are critical life safety systems, and it is essential to ensure that they are properly designed, installed, and maintained. Failure to do so could have serious consequences. This information is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with a qualified professional for specific design and installation recommendations. Additionally, always refer to the latest edition of the NEC and any applicable local codes and regulations. Electrical codes and standards are constantly evolving, and it is important to stay up to date with the latest requirements. By following these guidelines, you can ensure that the electrical system for your fire sprinkler motor is safe, reliable, and compliant with all applicable codes and standards. Choosing the correct wire gauge ensures that the electrical current can flow safely to the motor without overheating the wires, which could cause a fire. Selecting the appropriate circuit breaker is essential for protecting the motor and the electrical system from overloads and short circuits. Using components with the correct specifications and certifications guarantees that they will perform reliably and safely under the conditions they are designed for, which is crucial for life safety systems like fire sprinklers. Staying informed about the current electrical codes helps ensure that all installations meet the latest safety standards, reducing risks and improving overall system performance. All installations should be performed by qualified electricians who can verify that the system meets all applicable safety and regulatory requirements. Regular inspections and maintenance are essential for ensuring the long-term reliability and safety of the fire sprinkler motor and its electrical components. Correctly sized and installed components can lead to improved energy efficiency, reducing operational costs over the lifespan of the motor. By adhering to these guidelines and best practices, you contribute to the overall safety and reliability of fire protection systems, which are vital for protecting lives and property. Always prioritize safety, compliance, and professional expertise in all electrical work related to fire sprinkler systems. This detailed approach not only ensures safety but also optimizes the system's performance, extending its lifespan and minimizing potential disruptions. Continuous learning and adaptation to new technologies and standards in electrical engineering are key to maintaining the highest levels of safety and efficiency in fire protection systems. This includes understanding the latest advancements in motor control, protection devices, and wiring methods. It's also important to consider the specific environmental conditions in which the motor and electrical components will operate. Factors such as humidity, temperature, and exposure to corrosive substances can impact the selection of materials and components. Using corrosion-resistant materials and appropriate enclosures can help extend the life of the system and prevent failures. Another important consideration is the coordination of overcurrent protection devices. Coordination ensures that the circuit breaker closest to the fault will trip first, minimizing the impact on the rest of the electrical system. This can help prevent nuisance tripping and ensure that critical loads remain operational. Proper grounding is also essential for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. This helps prevent electrical shock hazards and reduces the risk of equipment damage. When installing conductors, it is important to follow proper wiring practices. This includes using the correct wire connectors, ensuring that connections are tight, and protecting conductors from physical damage. Improper wiring can lead to loose connections, overheating, and electrical fires. It is also important to properly label all conductors and circuit breakers. Labeling helps identify the purpose of each conductor and circuit breaker, making it easier to troubleshoot problems and perform maintenance. When selecting a circuit breaker, it is important to consider the available fault current at the point of installation. The circuit breaker must have an interrupting capacity that is equal to or greater than the available fault current. If the interrupting capacity is too low, the circuit breaker may fail to interrupt the fault current, which could lead to a dangerous electrical arc and equipment damage. Regular testing and maintenance of the electrical system is essential for ensuring its continued safety and reliability. This includes testing circuit breakers to verify that they trip properly, inspecting conductors for damage, and checking connections for tightness. Any problems that are found should be corrected promptly. Fire sprinkler systems are an essential part of building safety, and it is important to ensure that they are properly designed, installed, and maintained. By following these guidelines and working with qualified professionals, you can help protect lives and property from fire. Always consult with a licensed electrical engineer or certified electrician for specific guidance on your project. They can assess your specific needs and provide recommendations that are tailored to your situation. Electrical codes and standards are subject to change, so it's important to stay up to date on the latest requirements. This can be done by attending industry training courses, reading trade publications, and consulting with experts in the field. Proper documentation is also essential. Keep records of all electrical work that is performed, including wiring diagrams, equipment specifications, and test results. This documentation can be helpful for troubleshooting problems and performing maintenance in the future. Investing in high-quality electrical components is a worthwhile investment. High-quality components are more reliable and durable, and they can help reduce the risk of electrical failures. When selecting electrical equipment, look for products that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the product has been tested and meets certain safety standards. Always follow the manufacturer's instructions when installing electrical equipment. The proper installation can lead to electrical hazards and equipment damage. If you are not comfortable performing electrical work yourself, hire a qualified electrician to do the job. Electrical work can be dangerous, and it's important to take precautions to protect yourself from electrical shock. Always turn off the power before working on electrical circuits, and use insulated tools. Avoid working on electrical circuits in wet or damp conditions. If you see any signs of electrical problems, such as flickering lights, sparking outlets, or burning smells, contact a qualified electrician immediately. Do not attempt to repair electrical problems yourself unless you are qualified to do so. Electrical safety is everyone's responsibility. By following these guidelines and taking precautions, you can help protect yourself and others from electrical hazards. Never take shortcuts when it comes to electrical safety. Always follow the proper procedures and use the correct equipment. If you are unsure about something, ask for help from a qualified professional. Remember, electrical work is not a do-it-yourself project. It's important to have the knowledge and skills to do the job safely. Hire a qualified electrician for all electrical work that you are not comfortable performing yourself. This information is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for specific guidance on your project.